Alright, we're about to learn how Thomas Hunt Morgan used flies to discover that chromosomes were the material carrying our genetic information. Now, why did he use flies? Didn't Mendel use the peas? Well, turns out peas weren't that great of a organism to use to discover things in genetics. For one, it takes a garden to grow them. And Thomas Hunt Morgan was doing his studies in New York City. He didn't have a garden. Now, Mendel wanted to use peas because he also had to feed all of his fellow monks. So, no peas for this guy. Instead, he uses the fruit fly, Drosophila melanogaster. Now, if you know anything about these flies, you've probably seen them or at least one of their close relatives. If you've ever thrown away some stinky garbage, maybe went away for the weekend, left your fruit rotting, you come back, here's these tiny little flies all over the place. So he chose these flies. It takes them only about 2 weeks to grow to reach an adult, and they reproduce rampantly. It wasn't any problem to go through multiple generations in 2 weeks, a new generation. Now with the peas, it obviously took a whole growing season. 1 year, 1 generation of peas. 2 weeks, 1 generation of flies. Now, flies are one thing. This was about 1908 that Morgan discovered his first mutant fly. Now, this was very, very important if you're looking for the genes or where these alleles actually are in an organism. You find a mutant, that might be of particular interest. So what do you do? This white-eyed fly was a male, and so what he did, aside from babying it, making sure it stayed alive, he bred it with a totally normal female. And this is our new term, what we call the wild type. Wild type just means that it's the type of fly that you would expect to find in the wild. No mutation. Now, for simplicity, let's just assume that we are assuming the same thing that Morgan assumed, that Mendelian genetics. Here's the recessive allele. We're going to assume that this is a recessive allele. So this is not the cross for these two guys. If this is a recessive allele, this would be a little a. So all of these would be little a, big A, all the way around, if bred with a homozygous wild type. So what did he get? Well, he got what you would expect. He got all regular flies. No mutants, no white eyes. So far, looks like this might be right. The old Mendel Punnett square. Then what he did is he took these new first generation from the mutant and wild type mother, bred them with yet another mutant wild type. Now it's important, he didn't just use one fly. Obviously he used them all. Well, not all of them, but do this obviously more than once. So what he did, that's of particular interest to us, is he took the females. Now, we're assuming that the females are all going to be heterozygous. That's because homozygous must give us a heterozygous. Now combined with this, according to this Punnett square, which is what we would expect if Mendel was completely right, this little a would go across and we would get no homozygous mutants, so no white-eyed flies. But instead, what he actually found was that 50% of the males had white eyes, mutants. The other 50% were normal. But, well, actually that's a female. Other 50% is normal. All the females were normal. And this is kind of interesting, right? So if you ignore the females, it looks like, if we ignoring this, it just doesn't really make sense. But now what they did know at this time was the difference in chromosomes. They couldn't prove that having a Y chromosome made an organism male. There were obviously going to be skeptics who said being male makes this chromosome shorter, makes it a Y chromosome. So remember, correlation does not imply causation. But Morgan had a hunch. Maybe in these females there was the mutant gene, which was being masked by the wild type X chromosome from the father. Now, if that's the case, what happens if the mutant allele is here in a male? There's no region there to cover it up. Morgan has a hunch that that's what's going on. But this wasn't the only study with mutant flies that's of interest to us here.